In this section, we'll discuss the basics of how heat energy is transferred to and from the body. All heat energy moves from a heat source to a heat sink. The source is the hotter place and the sink is the colder place. The difference in temperature between the source and the sink controls how fast the energy moves. Heat will move more quickly from a hotter source to a colder sink. Traditionally, there are three major mechanisms by which heat is transferred: conduction, convection, and radiation. We'll also discuss another mechanism, phase shift, which is an effect of one of the other mechanisms but plays a really important role in heat exchange on the body. Conduction is the form of thermal transfer that takes place when two things are in direct contact. The molecules of the hotter object, or the heat source, will be vibrating more than the molecules of the cooler object. When the molecules of the two objects come in contact, the vibrating hot molecules will bump into the colder molecules and cause them to also vibrate. The thermal energy then propagates through the material from molecule to molecule. As I mentioned before, the rate of transfer depends on how big the temperature difference is between the two objects. However, it also depends on the properties of each object. Some materials conduct heat more easily than other materials do. Metals are probably the best conductors that you're familiar with. If you touch a hot metal surface, it will transfer its heat energy more easily to you, making it seem hotter than a wooden surface of the same temperature. The rate of conductive transfer also depends on the amount of contact between the two objects. So if one object has a rough surface and the other has a smooth surface, there'll be less surface area in contact between them than if they were both smooth. This is why a cold satin shirt would feel colder against your skin than a cold shirt with more texture, even if they're actually the same temperature. Convection is a form of thermal transfer that takes place when molecules of different temperatures intermingle or mix. You probably know it most commonly through convection ovens, which mix air of different temperatures to speed up thermal transfer. Another example you will have experienced is what happens when you pour hot water into a cool bath. For convection to occur, the materials don't have to be exactly the same, like hot water and cold water, but they do need to intermingle molecules. For example, if you poured hot water into cold oil, only conductive transfer would happen between the oil blobs and the water blobs because oil and water repel each other, so they won't let their molecules actually intermingle. Convection in air often happens because hot air rises in Earth gravity. Hotter air moves upwards and mixes with cooler air. In space, this doesn't happen because there isn't enough gravitational force. Hot air just expands and moves outwards, but it doesn't float up. Wind chill effects are one example of how convection can affect thermal environments. The movement of air speeds up the rate of radiant thermal transfer, which is why cold, windy days feel colder than cold, still days. Your body heat is taken away more quickly through moving air currents. Finally, radiation is the only form of thermal transport that doesn't rely on thermal energy being transferred through molecules that are touching other molecules. Radiation is how energy travels through the vacuum of space from the sun to the earth. Energy is transmitted through photons, which are tiny packets of energy traveling in electromagnetic waves. When photons bump into molecules, they transfer their energy to those molecules. So radiation is the form of energy transfer that does not rely on contact between molecules or objects. Because radiation is a form of light energy, it can be manipulated like light. It can be reflected off of shiny surfaces to redirect the energy back to the source or to bounce it off in a different direction. It can also be diffracted, which changes the direction of the path of the wave, which means that it can be focused through a lens. This is how you can burn things with a magnifying glass. It focuses the thermal radiation into one spot, increasing the amount of energy that's transferred to that spot. The last mechanism I want to talk about here is phase change. Phase change happens when molecules of a substance shift from one phase to another, moving between solid, liquid, and gas. Energy is absorbed when a substance moves from solid to liquid or liquid to gas, and energy is released when a substance moves from gas to liquid or liquid to solid. This phase shift accelerates the rate of thermal transfer, so in a lot of what we'll talk about in the next few sections, we need to pay attention to when phase shift is happening.